Quasi-experimental design.
So far, we have examined both weak and strong experimental research designs.
However, in social science research, for instance education, there are times when investigators face situations in which all the requirements of a true experiment cannot be met.
For example, sometimes it is not possible to assign students to groups which are a requirement of strong experimental research.
Due to logistic reasons, it is challenging to randomly assign subjects to groups, and so a whole class may have to be used in the research.
Is it still possible to do an experiment despite these limitations? The answer is yes, you can use a quasi-experimental design.
According to Christensen and Johnson, a quasi-experimental design is an experimental research design that does not provide for full control of potential confounding variables.
In most instances, the primary reason that full control is not achieved is because participants cannot be randomly assigned.
Non-equivalent control group design.
The non-equivalent control group design contains an experimental and control group, but the subjects are not randomly assigned to groups as stipulated in Figure 7.7.
Non-equivalent control group design.
The fact there is no random assignment means that subjects in the experimental group and control group may not be equivalent for all variables.
For example, you could have more poor-performing students in the control group compared to the experimental group.
Hence, it may be difficult to establish whether the better performance of the experimental group is due to the treatment or because there are more high-performing students in the group.
In the non-equivalent control group design, both groups are given first a pre-test and then a post-test, after the treatment is given to the experimental group.
The pre-test score and the post-test score are compared to determine if there are significant differences.
When you cannot assign subjects randomly, you can be sure that extraneous variables or factors will influence the experiment and threaten its internal validity.
Do you leave it alone or do you take action regarding the external threats?
Knowing that extraneous factors will creep into a quasi-experiment, a good researcher will take steps to ensure that the subjects in the experimental group and control group are as similar as possible, especially pertaining to important variables such as academic ability, attitude, interest, socio-economic status, and so forth.
How do you address this issue?
Cook and Campbell propose the following steps to enhance the internal validity of the non-equivalent control group design or quasi-experiments in general.
Selection.
Ensure that subjects in the experimental and control groups are matched in terms of important variables that may affect the results of the experiment. For example, match subjects in terms of academic ability, IQ, attitudes, interests, gender, socio-economic background, and so forth.
Testing.
Ensure that the time period between the pre-test and post-test is not too short that subjects are able to remember the questions given to them earlier.
History.
Ensure that events outside the experiment do not affect the experiment. The problem is most serious when only subjects from one of the groups are exposed to such events, for instance motivation talks, private tuition.
Instrumentation.
Ensure that the pre-test and the post-test are similar. If a different test is used, you should make sure that the two tests are equivalent in terms of what it is measuring, for example, high reliability and validity.
Interrupted time series design.
The interrupted time series design requires the researcher to take a series of measurements both before and after the treatment.
A single group of subjects are pre-tested a number of times during the baseline phase, exposed to the treatment, and then posted a number of times after the treatment.
Baseline refers to the testing done before the treatment designed to alter behavior.
A hypothetical example may illustrate how the interrupted time series design is used.
Say that you want to determine whether positive reinforcement encourages slow learners to be more attentive.
Identify a group of 11-year-olds who are slow learners and persuade them to attend an experimental classroom for at least one period each school day as in the figure. In this classroom, subjects are taught reading skills in a positive environment where they are praised and rewarded for their cooperation and attention on the given task activities.
Before the students are sent to the experimental classroom, their behavior is observed over 3 sessions in their regular classroom with regard to their attentiveness.
This is to obtain baseline data whereby their behavior is recorded in its natural state.
The treatment lasts for 3 weeks, and after the treatment, the subjects are observed for their attentiveness and focus.
Percentage of students observed to be attentive and focused.
The results of the hypothetical experiment is shown in Figure 7.9, which illustrates the percentage of students who are attentive and focused on the given task.
From this graph, you can see that the percentage of attentive and focused students who were assessed multiple times prior to and after implementation of the positive classroom environment, which results in an interrupted time series design.
This assessment reveals that the percentage of students who were attentive and focused remained rather constant during the first 3 baseline class sessions, or the class sessions prior to the implementation of the positive classroom environment.
After the implementation of positive classroom environment, the percentage of attentive behavior increased gradually over the next 3 class sessions, suggesting that the implementation of positive approach had a beneficial effect on the behavior of inattentive students.
Self-check.
What is the meaning of non-equivalent in the non-equivalent control group design?
How can you enhance the internal validity of quasi-experimental research designs?
When would you use the interrupted time series design? During World War II, Nazi scientists conducted some gross experiments such as immersing people in ice water to determine how long it would take them to freeze to death. During World War II, Nazi scientists conducted some gross experiments such as immersing people in ice water to determine how long it would take them to freeze to death.
They also injected prisoners with newly developed drugs to determine their effectiveness, and many died in the process.
These experiments were conducted by individuals living in a demented society, and they were universally condemned as being unethical and inhumane.
Research in education involves humanized subjects. Students, teachers, school administrators, parents, and so on.
These individuals have certain rights, such as the right to privacy that may be violated if you attempt to obtain answers for many significant questions.
Obviously, this is a dilemma for the researcher as to whether to conduct the experiment and violate the rights of subjects, or abandon the study.
Surely, you have heard people say, "I guess we are the guinea pigs in this study." Or "We are your white rats." Any researcher conducting an experiment must ensure that the dignity and welfare of the subjects are maintained.
The American Psychological Association published the ethical principles in the conduct of research with human participants in 1982.
The document listed the following principles.
In planning a study, the researcher must take responsibility to ensure that the study respects human values and protect the rights of human subjects.
The researcher should determine the degree of risk imposed on subjects by the study, for instance, stress on subjects required to take drugs.
The principal researcher is responsible for the ethical conduct of the study and be responsible for assistants or other researchers involved.
The researcher should make it clear to the subjects before they participate in the study regarding their obligations and responsibilities.
The researcher should inform subjects of all aspects of the research that might influence their decision to participate.
If the researcher cannot tell everything about the experiment, because it is too technical or it will affect the study, then the researcher must inform subjects after the experiment.
The researcher should respect the individual's freedom to withdraw from the experiment at any time, or refuse to participate in the study.
The researcher should protect subjects from physical and mental discomfort, harm and danger that may arise from the experiment.
If there are risks involved, the researcher must inform the subjects of that fact.
Information obtained from the subjects in the experiment is confidential unless otherwise agreed upon. Data should be reported as group performance and not individual performance.
Activity.
What are some ethical principles proposed by the American Psychological Association with regard to doing experiments involving human subjects?
Make a case for the superiority of true experimental designs.
What are the quasi-experimental research designs and how do they differ from true experiments?
Discuss the circumstances in which researchers have to use intact groups.
What can a researcher do to increase the equivalence of subjects in the control and experimental groups in a quasi-experiment design?
Graph the following data from an experiment on the effect of lighting and music on anxiety.
The scores are means of an anxiety test.
Summary.
A research design is a plan or strategy specifying the procedure in seeking an answer to the research question.
Weak research designs do not allow for the control of extraneous factors that might influence the experiment.
Examples of weak designs are one-shot design, one-group pre-test, post-test design and non-equivalent post-test only design.
True experimental designs enable the researcher to maintain control over the situation in terms of assignment of subjects to groups.
Examples of true designs are after-only research design, factorial design and before-after research design.
A quasi-experimental design does not provide for full control of potential confounding variables.
Examples of quasi-experimental designs are non-equivalent control group design and interrupted time series.
Researchers conducting experiments involving human subjects should respect the confidentiality of subjects.